Now let's start with the concept of elasticity of demand. Now, before studying what is elasticity of demand, let us first understand what is elasticity. Elasticity basically shows the responsiveness of one variable to the change in another variable. If there are two variables, x and y, okay, and they are related same, okay. So if y changes, x may change. If they are related, say x equals to 2y, okay. Now the value of x depends upon the value of y. So if the value of y changes, x will respond. Now that respond of x to change in the value of y is basically known as elasticity. Okay. So elasticity is nothing but the responsiveness of one variable to another variable. Okay. You can from the name itself you can take an example. Elasticity can be related to elastic. Okay, the elastic that we use in clothes. Now the elastic respond to force. Now when we pull it, when we apply force, it stretches, and when we change the force, that or if we release the force, it comes back to its original shape. So what do we see over here? The elastic responds to force, so it also has an elasticity. Okay, so elasticity is nothing but responsiveness of one variable to another variable. Now the demand, for demand also we can study elasticity. We know that demand depends upon, the quantity demanded depends upon price of the commodity, price of related goods, income, and taste and preference. So we will exclude taste and preference over here. So basically we will consider only three factors of individual demand. Now we can keep these two constant and only study the relationship between these two. Okay, we can study the relationship between quantity demanded and price of the commodity. If price of a commodity changes, it increases or decreases, then obviously the quantity demanded will react. If the price of the commodity increases, the quantity demand will fall. If the price of the commodity decreases, the quantity demand will increase. Okay, so what do we see? That quantity demanded has a negative relationship with the price of the commodity. So this reacts to the change in this variable. These two are variables. This reacts to a change in this variable. So obviously there is a elasticity in between them. And when we study the elasticity between price of the commodity and the quantity demanded, we termed it as price elasticity. It is denoted by EP, ED. If we study price elasticity of demand, it can be denoted as ED or EP. Okay. Similarly, we also know that the quantity demanded depends upon the price of related goods. So when we study the relationship between quantity demanded and the price of related goods, keeping income and price of commodity constant, then also we know that if the price of related good changes, quantity demand may change. Say we are studying the quantity demanded of a TEA, and we are studying the relationship of quantity demanded of tea with the price of coffee. If the price of coffee goes up, the quantity demanded of tea will go up, as it is a substitute good. Okay, so and if it goes down, it will also go down. So what do we see? If the price of coffee changes, it is not price of a commodity, rather it is price of coffee over here. Okay, don't confuse it with PC and this PC. Don't confuse these two. So what do we see? If the price of the related good changes, over here we have taken substitute goods. We can also take complementary goods. If the price of substitute good changes, the quantity demanded of tea would change, it will show a response or reaction. So when we study the reaction of quantity demanded to is price of the related goods, we say it to be a case of cross elasticity. And it is given as EC. Okay. Similarly, if we study the reaction of quantity demanded to income, it will be known as income elasticity. Income elasticity. Okay. So I hope every one of you know the concepts, these three concepts and their formulas. The price elasticity of demand is given as ED equals to del Q by del P into P naught by Q naught. This is the formula for finding the price elasticity of demand. The cross elasticity is given as del Q, say del Q and price del P R into del P R naught by P R naught and Q naught. So here PR implies price of related good. Okay. PR naught implies the base price of the related good. And for income elasticity, it is depicted as EI, and the formula goes like change in quantity demanded to change in price to change in income into base income into base quantity divided by base quantity. So these three are the formulas for finding out the price elasticity of demand, price elasticity, cross elasticity, and income elasticity. So keep this formula in mind. This will be very helpful. Now we will quickly move our discussion to the types of price elasticity of demand. Types of price elasticity of demand, PP or ED, as you wish. Now, how many types are there? There are 5 types of price elasticity of demand. What are the types? We will draw the diagram and understand the concept in a very precise and very simple manner. We won't go into much of definitions, rather we will try to show the elasticities by the help of a diagram. So let us start with the first type of elasticity, price elasticity. The first type is elastic demand, and for elastic demand the value of price elasticity is greater than 1, and we know that the formula for the price elasticity is given as percentage change in quantity by percentage change in price. So for this ratio to be greater than 1, the numerator needs to be greater than the denominator. That means del Q should be greater than del P. Okay. So we have to draw the diagram and the demand curve in such a manner that the change in quantity should be greater than the change in price. So in order to show this, we can draw the demand curve a bit flatter. So this is the demand curve. Now take a base price P naught. The associated quantity will be denoted P naught will be denoted as Q naught, and take a current price as P1. The associated quantity will be Q1. Now visually you can see that change in quantity is greater than the change in price. So for this demand curve, the elasticity is greater than 1, and we can call this demand curve to be an elastic demand curve. So this is the first type of elasticity, price elasticity. Then let us move to the second type. The second type is inelastic demand. In this case, the value of price elasticity is less than 1. Okay, and according to the formula, that is percentage change in quantity divided by percentage change in price. Now for this ratio to be less than 1, the denominator needs to be greater than the numerator. Okay, that means the change in quantity should be less than the change in price. Only then this ratio will be less than 1. So in order to show this relation, we need to draw the demand curve bit steeper. Steeper in the sense, in this way. Okay. The previous one was flatter, now this one will be steeper. Consider this base price and the associated quantity is Q0. Consider another price P1, the associated price is Q1. Now you can see that del Q is less than del P. The change in price is greater than the change in quantity demanded. So for this demand curve, the elasticity is less than 1, or it can be termed as an inelastic demand curve. Then let us move to a unitary elastic demand curve. Third type is unitary elastic demand. Now for unitary elastic demand, the value of EP equals to 1, and going by the formula, now if we want this ratio to be equals to 1, then the numerator and the denominator needs to be the same. Only then we will get the value of this ratio to be equals to 1. That means change in quantity should be equal to change in price. So for drawing this relation, we need to draw the demand curve in form of a rectangular hyperbola. Okay, this is a rectangular hyperbola curve. Take the base price P0, associated quantity is Q0. Take the current price, current quantity. Now you can see that my diagram might be a bit faulty because the curve is has not been drawn perfectly. So however, roughly you can see that change in the price is equal to the change in quantity demanded. So for this curve, the value of elasticity is 1, and this curve is known as a rectangular hyperbola. Okay, this curve is known as a rectangular hyperbola. This is very important. Okay, and another thing I would like to give you information is that whenever you see any curve for the honor student, whenever you see any curve moving close to the axes, however it is not touching the axes, say it may be a indifference curve or it may be a rectangular hyperbola curve, these curves do not touch the axes. Okay, rather they move close to the axes. Now whenever you find this type of diagram, you will say that the curve is following a property of asymptotic. So this property of a curve of moving close to the axis and not touching it is known as asymptotic property. Keep this in mind. Okay. So we are done with the three types of price elasticity. we have more two to go. The fourth one is perfectly inelastic demand curve. Perfectly inelastic demand curve. Now in this case, the value of EP should be 0. So going by the formula, del Q by del P. Now for this ratio to be equals to 0, del Q needs to be 0. The numerator part needs to be 0. Okay. So to show this relation, the demand curve should be a vertical line parallel to the y-axis. Okay. So take a base price P0, you will get a associated quantity is Q0. However, if you change the price, the quantity still remains Q0. What do we see over here? That even if the price changes, the quantity does not change. So del Q is 0, whereas del P is something positive or negative, depends upon the change. Okay. Over here it is negative, the price has fallen down. So whatever it is, there is a value of del P. So the ratio would be something like 0 by del P. 0 divided by anything will give you again 0. Okay. So the value of, or the elasticity of this curve is what? 0, and it is known as perfectly inelastic demand curve. And the last but not the least, the last demand elasticity is perfectly elastic demand. Here the price elasticity is equals to infinity. Okay. And over here the diagram is of this shape. Okay. So in case of the last elasticity, that is the perfectly elastic demand, the demand curve is a horizontal line parallel to the x-axis. Okay. So we are done with the 5 types of price elasticity, and lastly now we will discuss the method of deriving elasticity by using the geometric method. We have done the percentage method. The percentage method was the formula that we have written in while discussing the concepts of elasticity are basically the proportionate methods formula or the percentage methods formula. And how the percentage methods formula is being derived? We know EP equals to percentage change in quantity demanded by percentage change in price. Okay. So this is the initial statement of the formula. And now we will derive the actual formula. So percentage change in quantity in price, del Q by Q naught base quantity into 100 as it is in form of percentage, then del P by P naught into 100 again as it is in form of percentage, 100 gone, we are left with del Q by Q naught and del P by P naught, and this can be written as del Q by Q naught into, as it is in the division form, if we apply multiplication to this, it will go as reciprocal. And lastly, what we can do, we can bring the del terms one side and keep the other terms together. Okay, so we shall use this formula as well as this formula while doing the diagram, while doing the sums. Okay, so this is the derivation of the formula of price elasticity, and according to the percentage method or the proportionate method. Now we will discuss the geometric method. Geometric method of elasticity, of price elasticity. Now, according to the geometric method, price elasticity is equals to lower segment by upper segment. Okay, so this is the demand curve, prices over here, quantity is over here. Okay, so first consider this point A. What is the elasticity at point A? At point A, at point A, EP equals to, the formula is lower segment by upper segment. So at point A, your lower segment is AB. Below the point you have the lower segment, and the segment is AB. Okay, and the upper segment over here is 0. You don't have the upper segment. The entire curves come under the lower segment over here, so it will be 0. Okay, so AB divided by 0 will give you infinity. So elasticity at point A is infinity. That is, elasticity at point A is perfectly elastic. Then let us come down to this point C. We have already used B over here, so we will consider it at point C. At point C, EP equals to lower segment by upper segment formula. Lower segment is CB, and upper segment is AC. Now for this point you have the upper segment. For the previous point you did not have an upper segment. Okay, so lower segment is CB and the upper segment is AC. Okay, now what do we see over here? CB, that is the lower segment, is obviously greater in size compared to AC. That means numerator is greater than the denominator. So obviously the value will be greater than 1. When the numerator is greater than the denominator, say let us consider a numerator 10 and consider a denominator 5. What do we see? The numerator is greater than the denominator, and if we divide we will get 2. So whenever we witness a case such as the numerator is greater than the denominator, the value of EP will be greater than 1. Over here, that is in case of the geometric method, we will not get a definite value of the price elasticity, rather we will get a rough figure. So over here, as the numerator is greater than the denominator, the price elasticity would be greater than 1. Okay, we are done with 2 points, more 3 points to go. So EP over here is greater than 1. Now let us consider this point D. At D, EP equals to, what is the lower segment? Let us bring D over it below. What is the lower segment? DB. And what is the upper segment? AD. AD is the upper segment, lower segment is DB. Now by visual observation we can say that DB is equals to AD. Both the distance look similar. Now if the denominator and the numerator are same, say 5, 5, both the numerator and denominator are same, then the value would be equals to 1. So at D, the elasticity is equals to 1. Okay, last, then at point E, at point E, point E, what do we see? At point E, the lower segment is EB and the upper segment is AE. And here the numerator, that is the lower segment is smaller than the upper segment. Okay, EB is smaller than AE. That means the value of EP will be less than 1. Okay, will be less than 1. And lastly, for point B, the lower segment is 0. That means numerator is 0, whereas the upper segment is AB. 0 divided by anything would give you 0. So elasticity at point B is equals to 0. So in this manner we will find out the elasticity at different points of the curve, okay, using a geometric method. We won't get exact figure of the elasticity, rather we will get a rough figure, okay, like greater than 1, less than 1. Okay, so this was all about elasticity, and we are done with today's class. We will meet in the next week.